Now we're on page 3 of the AP Chemistry Chapter 7 packet, and we're going to learn how to draw what are called energy level diagrams and also how to write electron configurations for the elements. So the electrons, as we learned, are in orbitals outside of the nucleus. In the last video we saw that. Let's take an example like sulfur. Sulfur has 16 electrons because it's atomic number 16, so 16 protons matches 16 electrons. We're going to be filling these electrons into different orbitals. This video is building on the last video where we learned that S's come in sets of 1, P's come in sets of 3, D's come in sets of 5, and F's come in sets of 7. So that's the number of blanks, tells you the number of orbitals. We also learned that energy level 1 only has S. Energy level 2 has S and P. Energy level 3 has S, P, and D. And energy level 4 has S, P, D, and F. Energy level 5 also has S, P, D, and F. However, we said that even though it also has a G, no elements are going to use that G orbital because it's not necessary. We don't even have enough electrons to fill a G orbital. So let's take these 16 electrons and put them into the orbitals. We put them up in order. So let's say you were rock climbing and you were climbing up a wall and you're looking for the next hold. The next hold is always going to be the closest hold that you could get to. So when you fill in the electrons, you could put 2 per blank. Usually we show it as an up arrow and a down arrow. The reason why I drew a half arrow is simply because it's easier and that's what most books will do. If that bothers you and you really want to draw the whole arrow, that's no problem. You could do it like that. Okay, so I'm going to do the half arrows. We're going to put them in every orbital. We go up, down first, so up, down. Now we put those into 1s. Now we're going to go to 2s. We're going to go up, down as well. When we get to the 2p, we're going to go up, up, up. Then we're going to go down, down, down. Let's take a quick story to understand why this is the case. If you were on the first day of school getting on the school bus and there were 3 empty benches, okay, you're going to get, and all the people on the bus are strangers, you're going to sit in the first bench by yourself, and every bench holds 2 kids. Now, the next person at the next stop gets on, they're a stranger, they don't know you. So they're not going to sit next to you, that's awkward. So they're going to sit by themselves. Then the third person gets on, again, that person's going to take a bench by himself or herself. Now, the fourth person who gets on the bus, there are no more empty benches, but there are 3 empty seats. So that fourth person, who is also a stranger, is going to sit next to you, and that's not going to be that awkward because there were no other seats. So it's the same situation with electrons. Electrons are all negative. Electrons repel each other. So they're going to go away from each other as much as possible. So the next electron is going to go here, and the next electron is going to go here, and that's 10 electrons. We have 6 more to go because sulfur has 16. So we're going to go next to the 3s, and we're going to go up, down, and then we're going to go to the 3p, and we're going to go up, 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 down. And now I have my 16 electrons, and this would be my energy level diagram for sulfur. You can translate this into what we call an electron configuration. So the electron configuration is simply writing this in one big line. So the 1s has 2 electrons in it, 2 arrows. So I write 1s2 right here. And then the 2s has 2 electrons as well. So I'm going to write 1s2. Even though these look like exponents, they're not exponents. They're just telling you how many electrons are in that orbital. Now 2p has a total of 6 electrons. So you could write 2p6 altogether, 2p6. 3s has 2, and then 3p has 4. So that's called the electron configuration. Now you could do a shortcut by looking for the noble gas configuration up to that point. So the noble gas before sulfur is neon. So if you look at neon, it has 10 electrons. So 2, 4, 6, 8, 10. And that's going to be up to 2p6. So if you put neon in a square bracket like this, that means neon's configuration, and then followed by what's after it would be 3s2, 3p4. So that's right over here. Another way to write this is in more detail, which we call the detailed configuration, and that tells you how many electrons are in each individual orbital. So remember how I told you that this came in X, Y, and Z for the p orbitals? So the X, Y, Z, we have 2, 2, 2, right? We have 2 in the X, so 1 on this part, 1 on this part. 2 in the Y, so 1 in this part, 1 in this part, and then 2 in the Z, which would be 1 in this part, 1 in this part. Now when we get to the level 3, we're also going to have an X, Y, Z. Actually, I'll try to match these colors. I should have done that before. So the P I did in green. So let me just write these in green here. So we had an X, a Y, and a Z. And then this is going to be an X and a Y and a Z as well. So that's also going to be one of these, but a bigger size than this. And then in the X, you can see on my drawing here, I have 2 in the X. So I'm going to have 1 here, 1 here. And then in the Y, I'm only going to have 1 electron. So let's say over here. And then the Z is also going to have just 1. So again, over there. So that's going to be what it kind of looks like. And then the S's, of course, we already mentioned. The 1S would be like golf ball size, 2 in there. And then this would be, let's say, tennis ball size over here, a little bigger. And then the 3S would be like a softball size. It should be like this big. And you would have 2 electrons in each of those S orbitals as well. So just to mention the rules here, they have official names. So the Aufbau principle means that you go up in order. Aufbau is the German word for order. So we go up in order, 1S, 2S, 2P, 3S, 3P. Next we go from 3P to 4S because it's lower on the diagram in energy than the 3D. Now that might be a little confusing, but you could just picture elementary school children. Okay, is it possible for a 3rd grader to be taller than a 4th grader? Yes, it is possible. But not usual, but possible. So the 3D can be higher in energy than the 4S. Okay, however, the 4 is still part of a higher level. So who's going to graduate first? The 4th grader or the 3rd grader? If all goes well, the 4th grader will graduate first. So that means this 4S is part of a higher level, although the 3D has higher energy than the 4S. So the 3rd level does have an orbital set that has higher energy than the 4th level. However, this is still part of the 4th, and this is still part of the 3rd. Okay, Hund's rule, you could remember 1, 1, 1. That's for the school bus story. So you're going to go 1, 1, 1, 2, 2, 2. And that, again, is because of electron repulsions. And lastly, the Pauli exclusion principle. You could think Pauli pair. You can only have 2 electrons per orbital. One goes up, one goes down in the spin. So that's just referring to the spin. So if the up one is spinning, let's say, clockwise, then the other one is spinning counterclockwise within the orbital. And that's the Pauli exclusion principle. You can also say no 2 electrons have the same quantum numbers, which we'll learn about in a little bit. So this is how you fill one of these energy level diagrams for any element electrons. In the next video, we'll talk about how to remember the order for all of this.